All right, sorry to start out with some notes, but we are continuing on looking at identities and learning new strategies to verify identities. So one is we had all those notes from the last task, and so you need to get to know those really well, especially your Pythagorean identities. And then the second key will be to pick a side to work on and don't touch the other. You're going to try to prove it the other side. So you only want to work on one side. And then you want to pick the more complicated side to work on first. And so we'll look at that with some examples today. Then after you pick which side you're going to work on, try to put everything in terms of sine and cosine. Get rid of those tangents. Use what tangent is equal to. You may need to find some common denominators, and it's okay to try several times. All right. So let's try one. And we also, you'll notice it'll say up at the top, like use distributive property to verify. Use algebra is basically what it's saying. Like we're going to look at some common algebra techniques. But remember, first we want to pick on which side we want to work on. And this black side over here is obviously the more complicated side. And then remember, we want to put everything in terms of sine or cosine. So I don't have to touch this. Sine of theta stays the same. Now remember, cosecant is 1 over sine. So I'm going to change that. This is just sine, so I'm good there. And this we're going to keep as it is because we're not touching this side. I'm not going to do whatever the side I pick not to touch. I'm not going to put it in terms of sine or cosine. And now I'm going to distribute. So I'm just going to multiply through. So first we get sine of theta all over sine of theta minus sine squared theta equals cosine squared theta. Now, what is this? Sine divided by sine is just 1. So this is really 1 minus sine squared theta equals cosine squared theta. So we do have a Pythagorean identity that uses sine and cosine. So that's your next strategy is like, okay, I've simplified it as much as I can. I'm in terms of all sine and cosine. Let me see if I can find an identity that relates this side to that side. And we have one. It's the most common Pythagorean identity where cosine squared plus sine squared theta equals 1. So we need to think of this in terms of what are other ways this could look, or what does cosine squared equal? Can I see if I can make this cosine squared equal something I can use here? And if I subtract sine squared theta from both sides, I see I get cosine squared theta equals 1 minus sine squared theta. All right, well, here's my substitution. So for this value here, I'm going to replace it with cosine squared theta, and I just proved my identity. Right, take a moment and finish your notes on that. If you pause, if you need to. We're going to look at a lot of examples in this video. All right, here's another one. I want you guys to do the most you can on this. So pause your video, use your notes, do the most you can, and then we'll come back and we'll do it together. All right, so hopefully you decided that this is the more complicated side. And then we need to put everything in terms of sine and cosine. So tangent is sine of theta all over cosine of theta. Cosecant is 1 over sine theta. cotangent is the reciprocal of tangent, so it's cosine theta all over sine theta. Now I'm not going to touch this yet. I'm going to leave it like that. And we're going to see what we get. Okay, so now I want to distribute because this shows multiplication. So I end up getting sine of theta all over cosine theta sine theta plus sine theta cosine theta all over cosine theta sine theta. Now these are just the same. I want you to realize that. So this can simplify to be 1. If I just rearrange these two, these are divided. And over here I can simplify too. What's sine divided by sine? Well, that's just 1. So I'm left with 1 over cosine theta. And we want to see, does that equal secant theta plus 1? Well, I'm really close. I have the plus 1. And if I go look at the definition of secant, I can see that secant theta is 1 over cosine theta. So I can substitute that in. And then I prove my identity. That one was a little bit harder. That's probably as hard as it would get for the ones that I want you to do on your own for this week. We're going to look at a couple more strategies though. This one, we want to just go ahead and turn everything into sine and cosine and see if it equals 1. So we have this sine squared theta, and cotangent is going to be cosine squared theta all over sine squared theta, and then plus sine squared theta, and we want to see if that equals 1. So when I multiply here, notice the signs are going to cancel out, and I'm left with cosine squared theta plus sine squared theta equals 1. And that's your most common Pythagorean identity, so then we can go ahead and say 1 equals 1. That one was a little bit easier. Right. I want you guys to try this one then. And let me, oh, there it goes. It finally focused. So hopefully you took a chance and paused this and tried this. So we're going to work on this side and leave this side alone. We want to turn everything in terms of sine and cosine. So cosecant is 1 over sine. So if it's squared, it's 1 over sine squared. And then tangent is sine squared theta all over cosine squared theta. And that all equals secant squared theta. That's what we're trying to verify. So if I multiply these through, I can see that my signs cancel out and I get 1 over cosine squared theta. And hopefully you remember that cosine is the reciprocal of secant. So at this point, I get secant squared theta equals secant squared theta. Most of your practice problems this week should be really similar. The only difference would be maybe you need to factor something out. Maybe it's already multiplied in and you need to factor it out. Just let me know if you have any questions this week. Schedule some office hours or come to Tuesday or Thursday at 1. Let me know what you need.